Hi students, welcome back. Today we are going to discuss 4 questions from the chapter Light. Here comes our first question. If the refractive index of water with respect to air is 1.33, what will be the refractive index of air with respect to water? For solving this problem, we are using this equation. Refractive index of air with respect to water is equal to 1 divided by refractive index of water with respect to air. One is the inverse of the other. Here you can see light is traveling from air to water. Air is a rarer medium and water is a denser medium. The speed of light in air is equal to VA and speed of light in water is equal to VW. Refractive index of air with respect to water is equal to speed of light in water divided by speed of light in air. Same way, refractive index of water with respect to air is equal to speed of light in air divided by speed of light in water. Now you can see that one equation is the inverse of the other one. If you multiply refractive index of air with respect to water and refractive index of water with respect to air, the answer is 1. That means 1 is the inverse of the other. You don't have to prove all this. You can directly write this equation. Here, refractive index of water with respect to air is equal to 1.33. If you substitute this value in our previous equation, you will get this answer as refractive index of air with respect to water is equal to 1 divided by 1.33. That's equal to 0.75. Okay, clear? Now we can move to our next question. The refractive index of glass is 1.5 and that of water is 1.3. If the speed of light in water is 2.25 into 10 to the power of 8 meters per second, what is the speed of light in glass? Here, the refractive index of glass means refractive index of glass with respect to air, or the absolute refractive index, that is equal to speed of light in air divided by speed of light in glass. Same way, we can find absolute refractive index of water is equal to refractive index of water with respect to air, that is equal to speed of light in air divided by speed of light in water. If we divide these two, that means refractive index of glass divided by refractive index of water, you will get the answer as speed of light in water divided by speed of light in glass. Here are the refractive index of water and speed of light in water. Here refractive index of glass and speed of light in glass. We can now use this equation Ng divided by Nw is equal to Vw divided by Vg. That means refractive index of glass divided by refractive index of water is equal to speed of light in water divided by speed of light in glass. If we substitute all these values, we can easily find out the value of velocity of light in glass, that is equal to 1.95 into 10 to the power of 8 meters per second. Our next question is, the refractive index of diamond is 2.42 and that of glass is 1.52. How much faster does light travel in glass than in diamond? Here the refractive index is equal to speed of light in air divided by speed of light in that particular medium. So we can compare these two. N1 is equal to C divided by V1 and N2 is equal to C divided by V2, where C is the velocity of light in air or in vacuum. If you divide these two, N1 divided by N2, you will get the answer as V2 divided by V1. Here, the refractive index of first medium divided by refractive index of second medium is equal to speed of light in the second medium divided by speed of light in the first medium. So V2 by V1 is equal to 2.42 divided by 1.52. Both these numbers are given in the question and the final answer is 1.59 approximately is equal to 1.6. We can write V2 is equal to 1.6 times V1, or speed of light in glass is 1.6 times the speed of light in diamond. I think it's clear. The velocity of light in glass is 2 into 10 to the power of 8 meters per second, and that in air is 3 into 10 raised to 8 meters per second. By how much would an ink dot appear to be raised when covered by a glass plate 6 centimeters thick? Just look at this figure. The thickness of this glass slab is 6 centimeters. We can denote this as T. And you look at this dot. This is the original dot, but it appeared to be in the new position. Let D be the shift in that position. Now you just consider what happens to this ray. It's because of the refraction of light. Here the equation refractive index of glass with respect to air is equal to velocity of light in air divided by velocity of light in water. That is 3 into 10 raised to 8 meters per second divided by 2 into 10 raised to 8 meters per second, that is 1.5. Now look at this equation. The shift D is equal to T into 1 minus 1 divided by N. Here D is the shift in the position of the dot and T is the thickness of the glass slab. Now we can substitute all these values here. Thickness is 6 centimeters and refractive index 1.5. Then the final answer is 2 centimeters. I hope you enjoyed this session. Practice more and more problems. All the best.